I think we're live.
Yeah,
Are we
we're
live?
live.
Welcome to this Weaviate Air. It's episode number 11, double one. This is super exciting. We kind of had a little confusion because I thought that Zen will kick it off, but I can do it, like you all used to this space, and making a lot of noise. So today is going to be really awesome. We have loads of great people on the call. We have a special guest, Ahmed from Beewant, who's going to do a really cool demo of something that he built with Weaviate, but also the whole business that he's building is super exciting. So I don't want to spoil it all just yet, but it's going to be super exciting. Of course, we have two new starters, people that just joined Weaviate recently. So we have Marion and Duda. They will say hi to you very soon and tell you what's what. And of course, Abdel comes to us to talk to us about some new indexing ideas and optimizations in Weaviate. This is really exciting stuff. He will get quite a bit technical, but it will be inclusive for everyone. And of course, the usual suspects, Zen and JP, well, and me. So this should be good. So Zen, how do we run it? What's up?
Yeah, so I want to start off with our main guest today, Ahmed. So welcome to the show.
Thanks for having me.
Yeah, it's going to be awesome. I'm looking forward your demo. Maybe we can start off by introducing you to the audience here at Weaviate.
Yeah, sure. I'm the founder and CEO of Beewant. So it's a French startup that helps organizations navigate through large amounts of unstructured data. And I remember last time with Sebastian, we had a great demo during the Intel Dev Summit. And today is going to be like different, but maybe we'll talk about that later. Okay.
Yeah. Awesome. Thank you. I think so. One of the great things that I liked about your platform was that you showed the demo in the Intel Summit, but outside of that, you've got a lot of other functionality as well, right? You showed me the entire pipeline that you use. Can you talk a little bit more about that before we get into the demo, new and improved?
Yeah, sure. I think when you approach AI in the enterprise world, you can just like talk about text only. You need to take into account like images, videos, audio, and other modalities. And most of the hype right now is around text. And I do believe that we need to include other modalities as well to have like a truly functional and useful product. And this is why we have a full workflow to just automate the building of an own AI for enterprises, which means that an enterprise can come with its data and then get out with like a fully functional AI that is specialized in its domain and for obvious reasons, for competitiveness, for innovation. And this AI that we build for our enterprises keep learning from new data. And that was like the main issue that we are solving, trying to solve.
Mm-hmm. Yeah, it's really interesting because there's this whole debate going on right now in the AI community where people are saying that language is enough to get us to AGI, and they believe like GPT 5, 6, 7, 8, 9 eventually will get to GPT AGI. But then there's this other school of thought, which you probably agree with, that you can't get to AGI without multimodal reasoning, right? It's not enough to just be a master of language. You have to understand other modalities like humans do to be able to breach this kind of barrier of AGI.
Yeah, absolutely. I mean, here we are talking, but your face expressions are important. Whatever happens outside of like language is really important. So, I mean, visual is I think is much more important than text only. So we tend to combine that with language understanding to have a kind of like a very good understanding of our words. Because I really believe that, and many others believe that text only is not enough. We're making progress toward AGI, but still, I mean, I've seen some research around like multimodalities where you have like depth, for example. This is something that we are like working on, but it's really tough to just make machines learn about depth. And there are a lot of other like modalities that could be really useful to achieve that AGI. But text only is, of course, just the beginning, and we are all grateful to ChatGPT to have made that possible and accessible to everyone. So this is just the beginning.
And I think even those companies. So if you look at Google, Palm, OpenAI, they're adding multimodality to their generative setups as well. The other interesting thing is that there's this paradox, Morvik's paradox, which says that a lot of the things that we think are very difficult are actually easy to compute. So like identifying or picking out images, like segmenting a radiology image, we think it's very difficult. Computers can do it. Like labeling thousands of images in a second, we think it's very difficult, but computers can do it. But a lot of the things that we take for granted, like when a child picks up a ball and then throws it, we can't really automate that. So that's where multimodality, I think, comes in, right? Because in order to a simple act of throwing a ball, you have to be able to control a lot of other modalities to action that.
Yeah, if we, if we make advancements towards understanding complex things like, touch and feelings and other modalities that we are living with like on a daily basis, that could be a great achievement. But from our perspective, if we manage to deal with text, images, videos, and probably audio, that could be like really good advancements. And of course, I mean, someday when we see the rapid race towards like AGI, I think in less than five years we'll see like systems that could understand the world as we humans do, and probably help us be more like efficient and amplify our intelligence. This is at least our goal at Beewant, is to enable humans with more intelligence and more analytics, and be able to act like an assistant rather than replacing domain expertise, which I believe is not yet there.
Yeah. So you were last time you showed me a great demo, and it got me all hyped. And then I shared that demo in some of my other talks. And then you mentioned that you have a new and improved demo. So you haven't told me anything else, and I tried to get some details, but it's been on the hush hush. So let's go into that demo,
Sure.
if you're ready. So let me share your screen on the main screen here. Okay. Cool.
Yeah, so as like you see, it's a simple interface, like a kind of ChatGPT interface. And today I'll be switching to two different domains, which are financial services and real estate. Financial services, because I used to work in that domain like for 15, 16 years. So I've seen a lot of enterprises struggle with financial analysis and all the legal documents, all the disclaimers, all that kind of reports and ESG reports. So I thought that having a system that could like specialize in financial services, that could be cool. And also I wanted to show like a demo about real estate, because This is a kind of like domain that hasn't been disrupted yet by AI. And so, yeah, let me start. So this is a guy that I like very, very much, Warren Buffett. And he's really like, he gives like wisdom advices. So probably sometimes when you have like a 2 or 3 hours video, you don't want like to watch the whole video. You just want to get answers for specific like questions. So this is something we are working on, and let me show you what we get in terms of results. So I just copied the video URL. I just push it here, and I process that video. And once it's processed, I can start asking questions. So I'm going to ask questions to Warren Buffett. So should we go to college to be successful? Because he was talking about success, so I guess this could be related. And so the system will understand what has been said during like the interview. So the answer is, according to Warren Buffett, going to college is not necessary for everyone. This is probably not an advice to follow for most of the people. So he believes that the best investment one can make is on oneself, and a lot of wisdom. And probably I can ask it, what are the biggest mistakes in investing? And so it goes on, like the biggest mistakes people make when investing, according to Warren Buffett, are trying to trade too frequently and not realizing, et cetera, et cetera. So this was like the kind of videos that you want to get answers for, but probably not willing to spend like 1 hour or 2 hours listening to the full video. Another use case for financial analysts is to be able to follow like earning calls or like profit warnings and all the kind of like events that happens in the financial markets. So similarly, I mean, I'm gonna add a new video and process it, and probably start asking some questions like how is interest rates impacting stocks. And it's gonna just like understand what has been said in the video and give me answers. This is, by the way, running on Intel 4th generation CPUs, which are really powerful and suitable for that kind of use cases. So yeah, one thing to mention is that outside of the context of the video, the solution doesn't answer. So if you ask it, for example, what do you want to have for dinner or for lunch, or should I go out tonight, it's not going to answer. It needs to be in the context of the video. So I'm not going to read like all the examples, but I see NVIDIA, for example, here, and I'd like to know more. So what does the video says about NVIDIA? So again, I mean, you don't need to watch the whole video. So the video suggests that NVIDIA expected to have a good quarter. This is the answer that I was looking for. Another use case is like a full interview of CEOs, and very often you have some tips for financial analysts that comes out of these interviews. And a lot of people are watching those interviews, especially for like CNBC or other big brands. And so I'm gonna take this one and start another processing. So how did NVIDIA grow from gaming to AI? So again, I don't want to watch the full video. I just want answers. I mean, how come like NVIDIA was known for gaming and now it's like the leader in providing like hardware for AI? And this is like the full story. So 2006, and NVIDIA released a software toolkit called CUDA, and you just have like the answers to your question. So now comes in the most interesting piece, which is the multimodalities. So I was wondering if NVIDIA is building their chips in the US or somewhere else. So what's the relationship between Jensen and TSMC? Sorry for the J. And so it's going to answer like my question. So Jensen, the founder of and CEO of NVIDIA, relies on Taiwan TSMC to manufacture nearly all NVIDIA chips. But yeah, I want to hear it. So I just showed the videos. And I don't know if you hear the sound of the video, but here the video starts where Jensen says to the founder of TSMC that it was his hero. So again, mixing modalities makes it like more fun and more efficient to understand. I said I was talking about like I was going to talk about financial services, but also real estate. And here we are going to visit like a mega mansion in Dubai. It's actually 60 million, so I'm expecting a lot from this mansion. And here we go. So I'm gonna process this video. So this video is like 39 minutes, full of images and some interesting stuff.
Is that a tour of your house, Ahmed?
Oh, I wish. So the video is processed, and let's say I'm a real estate agent, and I'd like to look for a beautiful house for my clients, and I don't want to see all of them, and I just want to see get answers for some of like the things that matters to my clients. And so I'm going to ask first to summarize the video. So the video is a tour of a luxurious mega mansion in Dubai. It describes like the mansion. But I can go further and say, list all amenities. And so here we get like a summary of all amenities, but I like to cook and the kitchen is really important to me. So I'd like to, my clients. So I'd like to see the kitchen. And so it's gonna describe a little bit like the kitchen, but also, so yes, I can show you the kitchen. The kitchen is in this property, super modern, has stunning marble counter. Yeah, that's really nice. So I'd like to see it. So here. So this is a very, very nice,
Seems
like
okay.
equipped, kitchen. So this is validated. But in Dubai, you know that people don't walk a lot. They use their car, and they have like very luxurious cars. So I'm wondering if there is any luxurious car, probably a Bugatti in the garage. For 60 million, I expect to have like a Bugatti included. So let's see what the system answers for that. Oh, yeah, this is a Bugatti Devo. But, I know the Bugatti Chiron, but Devo is something that I don't really know. So let's see it. Here.
I can see
So-
where we meet later on.
Carbon fiber and all that kind of stuff, full description. And I don't lose time. I just get right where my answer is.
Can you ask it like how many sports cars you saw?
I think there are a few Ferraris there. Shall we sports cars? Car? Yeah, probably. Yeah, we can see it like in the timeline. But I've already seen like this video. I think there are a bunch of like Ferraris and the Bugatti and so yeah, there is a Bugatti Devo, Porsche 918, Porsche GT2, a Ferrari Monza, wow, Ferrari 458. Yeah, so a lot of luxurious cars actually. As you can just so this was like the most luxurious car, Monza.
Excellent. This is an amazing demo. I love it. I like how there was this transition from like you are talking to this like to the AI, kind of like, hey, go analyze this video and I'll ask you a bunch of questions, and then you go like, oh, this is interesting. I want to actually listen to that part for myself. That's so super cool. Because then it could be a long video, right? Like you only interested in that one bit, but you don't remember what it was.
Yeah, I mean, in 20 years ago, I don't think I had a camera in my phone. Now I have 3 cameras in single phone. So you can imagine that a lot of people are shooting like videos, and those videos end up probably in the internet. And from what I have read, like 83% of all internet traffic is coming from videos. So we thought it could be like cool to have a tool to be able like to fetch those videos and understand what's being said and extract some value from those videos without spending too much time on it.
Totally. I mean, actually,
Really cool.
a great use case is Weaviate Air. We could at the end actually drop a link to Weaviate Air and start asking questions, right?
Why not?
That would be pretty cool.
Yeah. And I can add something. I mean, with the performance, like combined, like the combining like the power of the Intel CPUs and GPUs, and also the performance of the our favorite vector database, which is Weaviate. I think we can achieve real-time analysis on videos.
Nice. Hey, so we've got a question from the audience, actually from our CTO. So love this. Join late. Forgive me if you explained this initially. Are the videos frames transcribed stored as embeddings? How does it find the right time in the video?
Yes, that's right. I mean, we store every modality as embeddings in Weaviate. And we have like some techniques and algorithms that combine those like modalities to be able to find the right moment, find the right information to show. And, it's all about relevance. We don't want to have multiple results, but have like the most meaningful result. And yeah, everything is stored as embeddings, and Weaviate is kind of like central to what we do, because we need performance. We don't want to wait too much for queries. And when you deal with videos, you deal with a lot of information. So there is only, I think, one way to do it is using a vector database, and Weaviate is to our knowledge the best one.
Thanks for
Just
that.
for yeah.
Hey,
Go on, Zen.
one follow-up question to this. So a great demo, but one part of your demo kind of piqued my interest. So, and this is something different. When you searched for how is Jensen related to TSMC, I have an understanding of how it can generate an answer, but the timestamp also went to the part of the video where Jensen was talking about TSMC. The video doesn't show that he's talking about TSMC. It's in the audio. So do you guys have audio in there as well now?
Yeah, as I said, I mean, we work with a lot of modalities. We just store them all, and we have like our system just finding out what's the best thing to show. There are. Let me give you an example. Like you are driving and you hear music, like I don't know, your favorite music. If we translate that in a video, you will see yourself like driving and on the background having like some music. This is not really related. And so if we question that video, then we need to ensure that what we get as an answer wouldn't include like the background music, even if it's nice. So there are a lot of like playing with modalities. Just it's not just like about audio, but it's more than that. It's understanding what's meaningful for the users at the end, and not trying to replicate 100% how the brain works, but just trying to find like useful use cases that could amplify like the human intelligence and let us like interact with those videos in a seamless way.
That's so interesting. So you've actually got multiple modalities of search that are going in the background. I guess the next question, and perhaps this will be the last question for me, is you're doing image search in the background, text search, audio search. Can you tell us how you decide which one is of the most importance to answer any one question? So when you search about TSMC, the audio search is important, but when you search about Bugatti, the obviously the image search that's showing the Bugatti is important. So how do you say that audio is important now, but now image is important, or something else is important?
Yeah. I mean, you asked, or probably Sebastian, I don't know, I don't remember. You asked, how we deal with such modalities. We have like a data platform that we use to provide human feedback, and this human feedback is used to be able to retrain the model and have like an active learning loop. To be able to try to figure out which like modality is best suited for the answer. So it's probably working the same way as RLHF, and the more people will use the system, the more the system gets better in defining what's important and what's not, while getting their answers. So the answer is not straightforward, but it's kind of like reinforcement learning, and probably from a country to another, things might like change, and so we are just trying to figure out how best we can do that, especially that we have like some AI safety concerns, because the prompt is free. So you can ask whatever question you'd like, but we need to ensure that the answers are not biased and they don't contain like harmful content and all that kind of stuff. So there's a lot of work to do in that regard to ensure that these systems are safe for a larger audience. For now, we are focusing on the enterprise use, but probably later we want this system to be like useful for everyone, and for that we need to we have some additional steps to go through.
Super interesting. Thank you for the demo. the fusing of modalities is super amazing. Yeah, go ahead, JP. Sorry, I'm just amazed
Sorry to
here.
butt in. No, if I wanted to learn more about Beewant and whatnot, like what's the best place to go? Obviously, this is a locally hosted demo. Do they go to the website? Give you a phone call? No, I don't know. What do they do?
Yeah, for now we are targeting like enterprises because we believe that these kind of systems, multimodal systems, are more useful to enterprises for now. And so yeah, you can go to the website, or I can leave my details. And we of course we are happy to collaborate on any projects that is related to this kind of like research. And of course, I didn't show one interesting part is when you mix actually videos with documents. And this is really interesting because you get, especially in financial services, you get a lot of documents. So you want to send ESG reports and have an interview at the same time and see if there is any difference, if like the values of the company is really translated into these reports. So there are a lot of use cases, but I see those use cases for now in the enterprise world, and probably we'll find out if there are other use cases that could be applied to like larger audience.
Awesome, thank you for that. That was great. All right, so it's going to be tough to top that, honestly. It's going to be very difficult.
So we just stop. Is that what you're saying, Zen?
Yeah. The best for the beginning, and then there's nothing better than that. No, I'm just
okay. Bye.
All right. So next up, probably noticed Sebastian introduced Marian and Duda, so new members to the team. So let's hear a little bit about you. Let's introduce you to the Weaviate community, and yeah.
Yeah, thank you, Zen. Hi, welcome everyone. I'm Marian. I newly joined Weaviate as a community manager, and I must say, Ahmed, I was really amazed by that demo, and I probably can't top it. But I just saw throughout the whole demo, oh my gosh, how would that make my life more easier? Because we just conducted user community interviews. And I actually, recorded some of the feedback our community members had, and it would be so awesome, right? And I also took a lot of notes on paper, and it would be so awesome to kind of combine these documents together with what has been said, and just ask the question, did they find our documentation helpful, right? And then get it from the context. That would be amazing. So yeah, and that is a great bridge to what I wanted to say. I joined recently, as I said, and for us, community matters. That's why I'm here, and I want to spread, joy and happiness and really kindness into our community. And I also want our community members to be valued and to get the value out of Weaviate, right? So that's why we are starting with an initiative where we go out to our community members and ask them about, our documentation, new features, different use cases in Weaviate, and just ask them how they are finding their wows and their challenges, and learn from their feedback and just get better and make it more awesome. Maybe a little bit more about myself. I live close to Berlin, so I'm going to be around in a couple of events around here in Berlin, starting from now on. So keep your eyes open. And I'm also going to be at a lot of meetups, so you can meet me in person, and hopefully the rest of the team as well. And I will also be in the Slack community, hanging out with the Weaviate fans and everyone else. And that's the perfect time for Duda to introduce himself.
Hello, everybody. I'm Duda. I'm based here in Brazil. And just as Marian, but a little bit early, I also joined Weaviate, and it's been a very fun ride so far. Learning a lot, of course, as a a very full of potential tool that can be used to amazing stuff, just that Ahmed showed us. And I am the community technical manager support. So I'll be always there on the forums and also on the Slack and on the documentation, also with the help of GP and Zane. And so whatever thing that you need, if I am able to solve it, and if I don't, I also will bring that up to our team. So it's a pleasure to be here, and I hope to see you around there on the forums or our Slack. So please feel more than invited to join us there.
Awesome. Thank you, Marian.
Absolutely.
Thank you,
so great to have you all here.
Yeah.
It's nice to grow the family.
The team is growing. The team is growing.
So now we set the stage for the next for the next big thing, right?
Yeah. All right. So next up, got Sebastian talking about. What are you talking about, Sebastian?
Oh yeah, I wanted to talk to you all about online workshops. So it's pretty cool because both you and JP have been running workshops for a little while already. But in order to find them, it was a little bit tricky in the past because you kind of had to find them, like we would announce them on Twitter or like put it on LinkedIn or different places. And it was all about like, it's like, yeah, can you discover those workshops? So actually the two of you have been doing a pretty awesome job so far. We're running those workshops weekly. So for anyone that's watching us right now, if you're new to Weaviate, there's literally an intro to Weaviate workshop every week that is run online. 1 week is like more like a European/Asian time zones, while the other one is around the time zones that are friendly for the Americas. So those are great workshops to join. And how do you find out about those workshops? Pretty straightforward. You could go under developers and then into workshops, and then you can see like the future workshops. So for example, if you're interested in a workshop with JP tomorrow, that shows in my time. So I can click here and then you can go and register yourself for the workshop. So just drop us your name, email, and then we'll send you a link to the workshop, which will be pretty great. And then you get smart people like Zen or JP for a full hour or sometimes more. And a good thing about this is as well that this is a place for you to ask questions on how you do certain stuff, right? It's definitely recommended this one for anyone that's a beginner. So if you have somebody in your team that's learning Weaviate, send them over to this one. We're also thinking and already like somewhat in the midway planning other types of workshops for more advanced topics. So if you have any opinions on what kind of workshop you'd love to see for yourself, drop us a note either here during this session or maybe reach out to us on Slack. So yeah, that's me and the workshops.
Awesome. Thank you. If you want the smart workshops, you go to JP's workshops. If you want the fun ones, you come to mine. Okay, that's how we do it.
That's almost exactly what I was going to say, Zen. But I was going to say for actually learn stuff, go to Zen's. Just to listen to someone just go on and on. That's me. And then I do love to chat. And to Sebastian's point about coming in and asking questions, honestly, one of the best things about this workshop, and both Zen and I have said this, is just the fact that we get to engage with users about like how they're using Weaviate. And we've like actually ended up, talking to a number of people about and answering a bunch of questions, like not just during the workshop, but afterwards as well, because they had particular use cases. And then they, that wasn't covered in our examples, whatever, because they were unique. So yeah, it's a good time. Honestly, both of us. So, we're not horrible people, we think. So we'd love to have you.
The fun thing is that we sort of have a template for those workshops, but we don't. And then each of you run those workshops in a very different way. And I know that you keep trying new stuff. So it wouldn't even hurt someone to kind of join both or something, right?
Yeah.
But yeah, it's pretty cool.
Yeah, it's like a Pearl Jam concert. Every set's different. So.
Yeah, it's I want to keep it the same template, and then I get bored the first time I deliver it, and then I was like, okay, how do I make it better? So every time you come, you'll see a different demo, or you'll see something that's changed. So I've got.
That's why we need those advanced workshops, because if you get bored, you have to, show it with more advanced features and stuff, right?
Yeah, so we were planning on seeing what other concepts we can go into. So, for example, just an hour workshop on document chunking, an hour workshop on retrieval augmented generation, like all of these interesting concepts that um, another one could be like fine tuning embedding models. Like there's questions that we get from the community over Slack and over the forum, and it would be interesting to just pick one and then do a deep dive. I think that would be pretty interesting. So those are coming as well. All right, awesome.
Exciting stuff.
So this next topic is it's kind of near and dear to my heart because I've been learning from Abdel about this, and for I don't know how many Weaviate Airs you've been kind of hearing his thoughts through my voice, but today I wanted to welcome Abdel onto Weaviate Air for the first time, and so now you don't get the second-hand experience; you get the first-hand experience from the professor himself. So, Abdel, welcome, and it's great to have you here.
Thanks, Zain, and thanks for being the voice. I think you've done very well. I think probably it has heard better on your voice. So let's see. So I don't want to repeat everything you have said because again you have made terrific work. Of the address very much. I just want to talk about the last changes we did. So we released product quantization some time ago in version 1.18. It was under experimental flag because we knew it was not complete. Many things were still, so many pieces had to come into their place. But we wanted to test it a bit and to have some feedback. So back in version 1.18, we did some testing and we saw, okay, performance-wise, it's working fine, but we are losing a lot of recall. So the answers we are getting is not, well, they are not as accurate as we would expect. And then we analyzed this and we knew we could rescore all the data once we have it, but we still had a couple of policies to follow, like how Vamana does it, how HNSW PQ does it, like rescoring at the end, and we wanted to test everything before we ship a complete solution and we take the experimental flag out of it. So I have some charts maybe to show where we were back in 1.18 and where we are now. So this is this green curve. So this is queries per second against recall. So this is how fast we give an answer. Like we can serve 400 answers in a second or 100 answers in a queries in a second, and this is how accurate our answers are. Like one is like everything is what should be, like the closest points that we are trying to collect. And this was our results, no compression, no PQ, and this is what we get like with the relatively low compression, but high enough so as to compress that. So this orange curve is 6 dimensions per segment, meaning we had like 1 to 24 compression rate. So if you had like 24 gigabytes of vectors, suddenly you only need 1 gigabyte for storing them. But you see, there was a huge price in precision of the results. And then we explore the different ways. Like we could be rescoring, like, you know, I'll use your example. Like you have the address, you don't have the street numbers, you only have the street. Okay, it gives you an idea of the vectors you want to fetch. Mm-hmm. It's even more than that. If you live in a given street, let's come back to this example. When you apply the product quantization, it's not like you are taking the street and leaving the rest. It's a vector, and you have to apply some mathematical operations. So you could also add some noise in the street that you are storing. It could be not the real street, but the street next to it. And then you don't want to rely 100% on the street. You want to give some room for the noise. So ideally, you should say,
Oh,
Is it?
is that just me?
You're frozen.
That's what I was
Each
thinking
of us
as well.
I was
suddenly got
definitely-
quiet. Like,
I
was it
was
me? Was it you?
Everyone is like really silent. I was
doing
like,
that thing where like I'm
Yeah.
looking at other people's screens so I don't interrupt Abdel if he's still talking.
I think Abdel went into like the compress from 118, and that's the low recall.
I
So,
think he
really
enabled
decent
PQ
performance
while
related to
speaking.
Yeah, the old version
I'm
of
back.
PQ. The old version of
We're
PQ.
gonna
he's
get
back.
4-bit
Hey,
Abdel
Abdel.
back. There we go.
Did you just run into the old version of PQ of low recall? Nope.
Oh, it's gone again.
I think he's still on the old version.
You have enough points, and then you can collect the data. So you can check all the enough points to have a good result set. But how do we do then? We take all those vectors and we go to disk, take the real representation of the vector, recompute the distances, and take the final. So this made us jump from here to this range on recall. Like it's now really close to the on compress. And then we also made some improvements from 118 to 121. Now it's a bit hard to compare. So this is 118, no compression, 121, no compression. But we have
Hey,
now.
Abdel, we can't see your cursor, by the way. So
Okay, so the blue. Oh, sorry for that. The green curve is 118, no compression. The blue curve is 121, no compression. So you see, there's no PQ there, and still there's a huge difference, and that's because of the different improvements that we have introduced in Weaviate, like GRCP, gRPC support, like the SIMD optimizations on the distances calculations, which, by the way, are not supported for the compress case. So we still have some more research to do. And then if you see the red curve now, that's the compress on 121 is in a good, it's really close to the blue. So we believe it's really out of experimental. We have fixed enough bugs, and I think it's, well, we believe it's safe to use. When we made all those changes in 119, we then realized, okay, this is going good, but the indexing time was still like almost twice when you compress. And we debug it a bit, profile it, and we realized, okay, there's a lot of distance calculations between compressed vectors. And I don't want to get too technical now, but we have like this lookup table where we put all the distances for compressed vectors to the query vector. And we did something similar for the indexing. Like we have this global lookup table where you compute distances once and you don't do it again ever during indexing. You reuse it, and now when you index, let me see if I jump to the next. Yeah, when you index, so we try with Sphere dataset and with dbpedia. So we have dbpedia, a collection of 1 million vectors, vectorized with the OpenAI ADA 002. So those are big vectors. In 118, if you would index your data, compress and uncompress, you have like twice the time to index the data. But in 121, it's more or less the same. Actually, compress is a little bit faster, but not significantly faster. So it's more or less the same. And the improvement, of course, is so the benefits are in the memory footprint, where you barely need the 14, 15, 10% of the memory you would have needed for the normal use cases. So, for example, with Sphere 1 billion objects, we went from 2.7 terabytes to 0.7 terabytes, like maybe 5 times less memory. Yeah, that's
one of the amazing things about this. So can you go back to the first graph that you had there? This is what's the compression ratio between the blue and the red line that you're showing?
It's like the red curve needs 14% of the memory we need for the blue.
14%.
So it was like 6.5 gigabytes of memory against 900 megabytes, something like this.
Yeah. So like the fact that you're only paying this much recall for that amount of compression, and then depending on what your application is, of course, if you look at this is so awesome. Yeah, exactly. 85% reduction in memory footprint. And the other thing that I was talking to Abdel about this is that we're not only making improvements on that red line, that blue line, the uncompressed version, is also being improved day in, day out, right? So really for Abdel, who's working on the PQ stuff, the red line is chasing the blue line, and the blue line is getting better and better as well. So it's quite a tall order. So before it was closer, and then we made the SIMD improvements, like Abdel mentioned, and the blue line improved even more, right? So like for me, if this is another thing, I guess we're going to be releasing a blog post that has all of these details in the next couple of weeks. So look out for that if you want to learn all of these details from Abdel. But what's interesting is now you really have a valid choice in going full PQ, and you can kind of look and see what your data is equivalent to in terms of the tests that we've done, and see how much kind of recall you're paying for the up to 80-90% reduction in memory footprint. And
yeah, I also wanted to say here about the price you pay in recall, that so when we compare, we rescore down. So during the search, or we rescore at the end, we saw, okay, the curve is slightly higher. I mean, the recall was exactly the same as uncompressed if we would have rescored during the search. But then the performance penalty was higher. And with this, you have the flexibility to increase your parameters, your search parameters, like your EF parameter, and you can still get the recall you want at a lower price in performance. This is another way also to read it. You don't have to pay in recall. If you want a better recall, so you need to use a higher EF parameter compared to the uncompressed version.
Okay.
And then you might lose a few microseconds or maybe 1 millisecond, but that's it. That you still have an accurate solution.
I see.
And by the way, these charts. So I will also talk about how to benchmark your data in case you have your own data and you want to see how it goes. We are using scripts that are in the chaos pipeline currently in Weaviate. So I will put all the information you would need to replicate these experiments with your own data or with whatever data you need to run the experiments.
Yeah, that's going to be awesome. I think so. A lot of the questions that we get, especially after we ran the Sphere experiment, were people trying to replicate the Sphere experiment, and now like we're gonna release the code that you can use to kind of plug and play your own data set and try with PQ, without PQ, and then you can and then if you're modifying the parameters of HNSW to get some of the recall back, that's where I think it'll be super useful, right? Because then now you can fine tune some of the parameters of PQ as well as HNSW, and then you can see what amount of compression works for your data set. That'll be awesome.
Yeah. One thing that we didn't cover yet, sorry, JP, it's because we always talk about performance and like recall and everything, but like I think, and it's great that we have Ahmed here, because to people that build with Weaviate, that also means that financially you can build bigger solutions maybe. Like maybe before we say like, hey, 100 million, that was a wow thing. Now with 85% savings on the same setup, I could throw 700 million vectors, right? And then so you could kind of go like, okay, not only can I handle like way bigger data set, my speeds are even going up, but I'm not spending more on hardware. Like this is so incredible. So there's definitely a great opportunity for you to play. Because like if you're like on a small data set, like you're in like 500,000 objects, yes, it is a bit of an improvement, but when you deal with like huge cases, like this is like a wow thing. And then you could either go like, I could slash my costs a lot because I don't need so much hardware, or I could go like with my costs, I could go for bigger cases. And I think this is great. And I'm pretty sure, Ahmed, you're already messaging your engineers going like, yep, get on the latest version.
Yeah, so for Ahmed, I think there's two interesting things. There's the multi-tenancy update and then the PQ update. And so, yeah, lots of interesting things, which is a great segue to JP, who's going to be talking about some of these interesting updates. JP, what are you bringing us today?
Fabulous. I'll be pretty quick, but yeah, that video really reminded. So the talk really reminded me of, keep your Weaviate versions up to date, right? Because a lot of people ask us about like, oh, I'm having problem XYZ, and quite often the solution is, oh, have you tried the latest version? Because we've made improvements and what have you. And this is like a big example. And those curves with the uncompressed data is a big example of that, because even if you weren't using PQ, just by updating to the latest version, you get huge performance gains. Like the two uncompressed curves are like just wildly different places to each other. So that's really cool. But Zen, if you can share the screen that I've got open, I can talk through 121. Oh, that's interesting. Did that jitter on your screen as well? That was happening as...
Yeah, it jittered a little bit. I don't know why it vibrated.
Just very excited, Zen, just very excited. So 121 came out last week. It is now available on WCS as well, and you would have seen some social messages. So if you really, if you like this cute Weaviate guy, check that out as well. But there are a few features here that are really interesting. So I'll go through them one by one fairly quickly. So we've got new contains any, contains all operators. This is syntactic sugar. But what it really does is, I'll actually scroll down to the right section before I talk about it. But what it does is, instead of having to have a bunch of combinations of logical operators, like whether it's ands or ors, this allows you to streamline that. And it might, when I describe it, not like sound like a big deal because, well, you're doing the same thing. But if you're writing code or if you're reading it later, it will just like, it'll be easier to write, more likely to be bug-free, and easier to understand the logic internally, what's going on. So, and it doesn't really change anything else other than the fact that I'll use the GraphQL example here. You're just using a different operator right here. And in terms of contains any, this will replace a series of OR statements, which we've all written long, boring, involved logical combination states before, whether from Excel or in actual programming languages and whatnot. So this will make that a lot easier. So that's contains any and contains all. And it's now, I believe, supported in all of our client libraries as well. So please check that out. Cool. So that's that one. And the other one, and you touched on it earlier, Zen, in terms of really the relevance, Ahmed, and I'm sure you're, I see you sitting up, Ahmed, about the multi-tenancy improvements. And this is a cool one. So when we launched multi-tenancy, we talked about scaling aspects of it, right? How many, as a rule of thumb, how many tenants can we support per node and whatnot? Now, what we've done with this update, or not me, I didn't do any of it, but what the team has done with this update has been to introduce the ability to activate or deactivate tenant shards. Each tenant is a shard, and what this allows you to do is to say, if you have 1 million users and half of them are inactive users, you can just switch them, not necessarily off in terms of deleting them, but you can turn them into deactivated users, and they'll take up no memory footprint, basically, right? So you'll store all the data, you can activate them if they do come back online, but again, it's a really convenient way to scale without kind of wasting hardware resources on data and memory footprint that you don't need. So I believe it's somewhat experimental. So in the sense that the API might change a little bit. I believe there are more states coming and so on. But this is really, really cool. So again, if you're, building something with a bunch of tenants, and, this is like going to be a really good cost saving and useful feature for you, I think. And I'm going to scroll through all the pros. And there's been a performance improvement in terms of like how the system manages kind of coordinating all these different operations going on for multi-tenancy, because there's, large scale, lots of tenants, lots of things needs to be done. So basically that's an under the hood improvement though. So again, if you upgrade from 120 to 121, you get this for free, right? And who doesn't like free stuff? Okay, so we've got new modules. And Zen, I'll throw this back to you when I'm done rambling. And the first one is a text-to-vec GPT for all module. We've got the text-to-vec contextually module as a local vectorizer, and that works well. It's kind of an older model, so perhaps it's not as performant as some of the more modern models. And there was one solution to that is to use the text-to-vec transformers module, with which you can use any of the modern transformer architectures. Now, obviously, then many of you use that or know about it, know that you need a GPU. You kind of do really need a GPU if you want to do any kind of massive scale vectorization on it. But this module is optimized for CPU use. So it's got one of the mini LM modules available for it. And with this, you can get really, really fast vectorization or inference, whichever way you want to call it, performance out of just the CPU. So encourage you to check that out. And the next one, of course, we're really excited about is the multi-to-vec bind module. I can see Zen just vibrating or jittering with excitement there. And that allows us to use the bind model to process multi-modal data. And Zen will, show a cool demo after this. Zen gets to do all the fun stuff, but here's a little preview. So if you look at the blog post, there's a little demo here of like using, is it sound to retrieve images and a video to retrieve another image? Is that right?
Yeah. So this one, you can play the file at the top there.
There's a little
there.
link. So
So that's the sound of a car honking, and then this is the image that comes back. And I'll show in the demo what other things you can do. I guess I'll go into it when I go into the demo. Otherwise, I'm going to start rambling and then I won't stop.
Exactly. It's my time now, Zen. Go away.
He probably came up with this car because sports cars don't honk, They just run you over. So, yeah.
Listen, Sebastian, you need to pay us more for us to put pictures of Bugattis in here.
Pictures of Bugattis are cheap, man. You're not getting a pay raise just for a picture.
Well, I tried. So there's that. And then there's a couple other things I'll just go through quickly. So there's been a suite of performance improvements under the hood. So you can see the little Weaviate mascot being extremely happy. One of them that is not entirely under the hood is the virtual memory access. So mmap is the existing method or the existing function that's being used to map virtual memory and used. It can have some potential challenges if you start to have like basically significant load. So we've introduced this option under the hood to use pre-read. So default doesn't change. So if you don't do anything, nothing changes. But if this is a potential challenge for you, you can try out this solution. So we mentioned SIMD operations before. And for those of you like me who might not necessarily know what SIMD is, it's basically parallelization technique in processing. So if you're as old as me and seen things like MMX on stickers, it's kind of like the same thing on the old Intel chips. Now, this is already available on Intel processors, but we've added this for ARM64 processors. So that's really cool. And again, upgrade, you get free performance improvements. I feel like a salesperson. And Abdel would know this
Still
well.
not getting a pay rise.
Yeah, I'll weigh you down. And we get vector indexing improvements in terms of how the vector index is basically built and how it's used. So we've got these two key improvements in terms of how it's encoded and in terms of how it's accessed and what's available when to different processes. So these are under the hood improvements, and it'll just basically make Weaviate go even faster, which is really, really neat. One change that you probably want to be mindful of is the backups. There's a couple of things here. One highlight that you should know is that 121 backups cannot be used in 120. So if my sales pitch is successful and you do upgrade, before you upgrade, it might be a good idea to produce a 120 backup in case you do think you might want to roll back, production system or what have you. Because there are a whole bunch of improvements like compression that'll make the backups, I think, cheaper, certainly for cloud providers and potentially faster. I have to check, but it's not backward compatible. So back up your data and upgrade if you think you might be rolling back.
The most important thing about backups, use them.
Yeah. Make sure you back up to a medium that you can use. And one small thing, which is also quite important, is a hybrid search algorithm refinement. So with the new hybrid ranking algorithm that we introduced in 120, I believe, and that was to do with the way it was scored, there was a use case where if you retrieved on your small set of data, the results might fluctuate probably more than you might like. So we've introduced this little thing where even if you ask for like 3 objects, Weaviate will grab 100, right? And then calculate the scores and just give you back the 3, just because that stabilizes the way the scores are calculated. So you won't see it. You'll probably just notice that if you're using the relative score fusion, I think is the algorithm name. If you're using that, the scores are a little bit more stable than before. And so it'll be perhaps a little bit more intuitive when you look at the scores. So yeah, that's kind of it for me. It's a bit of a lightning round, but again, it's available on WCS. It's available open source. It's really cool. It's fast. It's got all these new bells and whistles on it. So again, please try it out and let us know.
Awesome. Thank you. I'm sold. I'm actually using it on this computer right now.
Nice.
I can prove it.
What are you doing with it, Zen?
Yeah, let me show you. One second.
Oh, wow. That's really cool.
So what I wanted to talk about was one specific module. So I've been playing around with this for a while. Let me show you guys here. So this demo is not going to be as cool as the demo that we saw earlier from Ahmed, but you can take the multi-direct bind module and you can kind of incrementally use it to get something that could be as cool. You're gonna have to put a lot of work in, but let me show you a little bit of the capability of the multi-direct bind. Before I go into the demo, so the model itself has the ability to encode 7 different modalities. And that means that you can perform any-to-any modality search, right? So you can pass in text and search for text, audio, video, images, and then there's a bunch of other modalities, but these are the exciting ones. And then you can do that with anything. So your query can be any of these modalities as well, and the output can be any of the modalities. So that's what I mean by any-to-any search. So the 2 modalities, and if I was going to show you all the combinations, we'd be here all day. So let me just show you some of the most exciting combinations. So what I did here is I put together a notebook to show you how easy it is, right? So setup is pretty straightforward. I've got this running locally on my computer. I've created a schema. This one has 2 classes, one where I'm storing images and another one where I'm storing audio. Depending on your use case, you can have one class that stores all the modalities or multiple classes that store different ones. But for my use case, I'm going to show you two different types of searches. One over image and one over audio. So I'm adding the data separately. And then I've got a bunch of helper functions here to kind of make the process a little easier. So then you go in, you add all the images. So I've got, I think, 20, 25 images. So it's a toy example. Maybe next time, I'm preparing a talk. So for that one, I'll have a real scalable example. And then I add the audio file. So I've got a bunch of audio files that I scraped from the internet. And then now we can perform, first I'll show you text, image, audio, video to image search. So here, you can go in and let's say we search for the concept a sparse market. This comes back. So this is nothing new. You could do this with clip. And then this works just as well. Actually, the image bind module is built on top of the clip module. So the image and the text modalities that it uses are clip. So this works as well as the clip module itself, right? So there's all of these. And then we can go to image search, which you can also do with the clip module. So here, the formatting is a bit wonky, but this is the query image. And then I can show you here. This is the query image, and then you get, I took 3 response images and I squished them together so you can see relevant things here. If this is your query image, you get the response image over here. If this is the query image, then you get response images. So this is all old stuff, right? So let me show you new stuff. So now you can play an audio sound. Let's say you wanted to query with this audio, and I don't know if this will play for you, but let me try it.
No.
Did you guys hear that? No? Okay. So I'll release this after. Yeah, so it's I'm not gonna, so this is
please make the voice.
So this is a car honking, and you have to trust me, and then I'll open source the demo afterwards.
Can you please do it?
And then so this is what you get back when you do that, which is interesting because you get the car, but then you also get the city, which is where now this demo is not as heavy hitting as if you could have heard it, but this is a lion roaring. And you get all this stuff back. And then you could keep playing around with this. So I've had a lot of fun with this. I'll release this notebook afterwards, so you can play around with this as well. You can kind of swap in and out the files that you're putting in. And then you can also do near video search. So here, this one you'll be able to see. So I've got this video that's playing. No audio on this one. And then when your query is a video, it goes in, and this is what you get back as response images. Now, keep in mind, in this class, I only have images, so it can only give me back images. If I had multiple modalities stored in this class, then I would be able to get back other things as well. Yeah, so if it's your query video, you can go through this. We get this response. If your query video is a bunch of lions, you get this back. And then
that's pretty amazing.
Yeah, so it's kind of, the first time I saw it, I was wowed, and then I played around with it for like 2 weeks. The other thing that you can do, so this is just images, right? You're getting back images. The other thing you can do, which is really cool, is, 1 second, let me scroll here. Your video search. So then the other class, I put in a bunch of audio files. So let me scroll down to this. Okay. So here, the query is this text, so animals on a farm, and it retrieves the audio sound that's most related to the animals on a farm. Right? And this is, you won't be able to hear this, but this is a rooster in the morning. Right? So you can play around with that as well. And then if you can query with an image, this is,
Yeah.
I'm not going to make the sound.
Oh, come on.
Maybe next time.
You're under friends here.
So if this is your query image, you get the audio of, so in this case, actually, it didn't return the audio of a badminton. That's because I had audio of badminton in the database as well. But apparently in this image, the man is more relevant than the fact that he's playing a badminton. So it sent me the audio of a man sneezing. I had both things in my database, and apparently that was closer in vector space. So I got a achu here. I made that sound. That counts. And then you can do query to query, right? So something like a Shazam app where if I play a tune, it will be able to retrieve a song for me. This one, I played a tune of a dog barking, and then it barks back at me. So it plays another audio sound here. And then
So
the
is
last
that-
one.
So
Oh,
we
oh,
could finally get an answer to what did the fox say.
yeah, but it'll be in fox speak. So these two dogs are kind of conversing with each other in multi-dimensional space. I don't know what they're talking about, but it's pretty interesting. And then the last one here, if you play, if I play a video, so if this is my query, the entire video, I can get back an audio sound here, which is just a school bell ringing, right, which was the closest thing to a classroom. So yeah, JP, you're saying?
Yeah, and each input here is being embedded into, like, is being converted into one embedding, right?
Yes. So there's multiple models. There's 6 different models. The one for image and video is the same. So that's why you have 7 modalities, 6 models. So the interesting part here is that you have 6 different embedding spaces, but each one of them is kind of binded together. That's why it's called image bind, by the representation of clip. So clip understands words and images really well, and the paper details this. They use clip's understanding of images and words to pull in the representations of audio, video, all of these other modalities to be close to clip. And so that's why even though you have all these multiple modalities, if I send in a video, it goes through a separate model. If I send in audio, it goes through a separate model. But the embedding space of all these modalities it kind of talks to each other in the training loop. So that's why you can kind of use these 6 models together at query time.
Yeah, and I guess from a user perspective, like how you decide to chunk, if you have a movie or if you have like I was talking about, you have an earnings call, right? How you chunk that would be really important, because you basically get an, or average vector for that segment.
Yes.
So if you have 2 very separate scenes after a scene transition, that might not be what you want. You want to have some way of intelligently chunking that information somewhere, which would be kind of, very important, depending on whether it's audio or video or a combination of both. It'll be like a fairly significant decision as to how you decide to do that.
Yeah, so if you wanted to, so this is where chunking gets really interesting. So if I play this video here, this video is entirely about the classroom, right? But if for some reason, partway through this video, you had a car or something like this, then it wouldn't work, right? Because then you're generating one vector, which is the average over 21 seconds, which is a lot. And you can read this in the papers as well, but per second, you generate 2 frames. So you get 2 image vectors per second, and then you do that over 21 seconds, and then you take the average over all of them. So you kind of squish together all these representations. If you have very diverse frames in a video, it's going to be very difficult. And this is where Ahmed's presentation comes in, right? So you have to do a lot more to deal with that. You have to do very interesting kind of chunking strategies and other algorithms to deal with that. But out of the box, the model itself just kind of squishes the entire thing together. If you have a big video, you probably do want to kind of semantically chunk so that you have one concept per vector.
That's awesome.
I mean, the cool thing is that because I've been playing the demo as well, the model, and at one point I use as an input a picture that we took from like basically UJP, Marian, and like Derek and Tommy, like were together, and we took a picture together. And we also, I think Derek was holding his dog. And the interesting thing was that like when I presented this picture for search, the output that I got back were pictures of people, like people gatherings, and there was also pictures of dogs. So the model was able to kind of like recognize like, oh yeah, this content is all about people and dogs.
Did you get meerkats?
Yeah, we didn't have any meerkat in the data set, but like Vasco is here with me, and he's sad. He's depressed now. He's like, "What do you mean, no meerkats?"
Yeah,
Meerkats.
we're gonna change that demo for next time.
Definitely.
Vasco.
The other interesting thing about this is that this has only been trained on kind of publicly available data. So I think this was trained on 9 different data sets that were stitched together. But if you want to use it for like very specific applications, then it won't know about those, of course. And this goes into what Ahmed was talking about. For that purpose, you have to fine tune the model to learn about a new concept, and then it'll be able to associate that new concept with other concepts that it already has in its embedding space. And that's where I think the potential for this can go through the roof. Right? It's really usable out of the box. It knows about a lot of general concepts, but if you have a proprietary thing that only your enterprise data has, then you can actually fine tune the model and then use it before you feed data into your vector database. And then now you have kind of customized multimodal search, which I think the potential for that is really great. All right, that's everything from me, folks.
And then do you throw it back to yourself as a host? No, sorry.
Yeah, I'm gonna throw it back to Sebastian to round us off.
Wait, me again? Okay. So thank you all for listening, for watching us. If you enjoyed this video, give us a like. Definitely come back for the next episode in a month. We'll do it again. If you have an exciting demo to show off, definitely would like to see you. A big thank you to Ahmed for his super nice demo. I was super exciting to see what you built, and yeah, definitely looking forward to see more of your work and what Beewant can do. I definitely recommend to anyone watching here, check Beewant, because that's an amazing company. Super exciting about finally getting the real Abdel, not to Zen proxy. So it's nice, always nice to have you here, my spider brother. And big welcome for Duda and Mario and the new starters. So yeah, and JP and Zen keep kicking and screaming. Maybe one day you wear me off and I'll get you that pay raise. So thank you for watching and see you next month. And yeah, once more, thank you for Ahmed for his special guest as a special guest. Bye.
Thank you, folks. Bye.
Bye.
Bye.